Hey math people, calculus concept check. Let's make sure you know what you're talking about. We have y is equal to sine x from 0 to 2 pi. I very much enjoy starting the conversation of derivatives and second derivatives with concavity and rates of change. That kind of part of calc, I really enjoy starting that with sine x because we can see within the image all four, and it's hard to see that there's four scenarios here. But we have four different scenarios. When your derivative and your second derivative are greater than 0. When your first derivative is greater than 0, but your second derivative is less. Okay. You have when your first derivative is less than 0, but your second derivative is greater. Right? And we have the final case here when they're both less than 0. Okay. Why do I like sine x so much? All four of these instances happen just within the first cycle of sine. So in the concept check, what are you doing right now? You're looking off this graph and you're trying to figure out, okay, for what intervals do we have these things going on? So pause the video now, try it out, go. Okay, so we have the first blue, I think it was actually the darker blue, even though it doesn't look like it, is when we are increasing. So when the derivative is greater than 0, this means that our slope is positive, and also our second derivative is greater than 0. This means we're concaving up. Another kind of interpretation is, and it's the same thing, is that your slope is getting faster over time. So where do we have positive slopes? We have a positive slope within this first window right here. This is actually from I don't want to mix up the colors. There we go, mix up. That's the word I was looking for. This is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. So clearly here within this first window from 0 to pi over 2, we have a positive slope. Negative in the next, negative in the third, and in the fourth window we're positive again. So among these two, when do we have a positive first derivative and a slope that is also increasing over time? It's concaving up. So looking at this window right here, notice how my slope is getting slower over time. I'm slowing down. Whereas from 3 pi over 2, I'm ramping up. I'm getting faster. My slopes are getting larger over time. So what are we looking for this first answer here? It's from 3 pi over 2 to 2 pi. Can you see that low down? Yeah, yeah. 3 pi over 2 to 2 pi. All right, so that's the, let's write it. Let's not worry about the endpoints too much right here. Let's just worry about the window inside. All right, so that is the first window. Maybe I'll just kind of do one of these. Right, done. Next window. When do I have a positive slope? Okay, same kind of deal here in terms of the first derivative, but my second derivative is negative, meaning I'm concaving down, or my slopes are getting less and less intense every time. Well, we just saw that in this window right here. So from 0 to pi over 2, our first derivative is positive, but our second derivative is negative. Next window, negative first derivative, positive second derivative. So my slope is negative, but I'm ramping upward. I'm getting faster over time though. So I have two separate intervals here. I have this first one, I have the second one. Both of them have negative slope. Okay, that one's a slightly easier one to maybe track. Think about what's happening to the slope over here though. Okay, it's getting more and more intense. It's getting further and further negative. This is an idea of concaving down, in which case the second derivative is negative in this window. If you notice these slopes in this window, we're getting closer and closer and closer to a positive value. Right here, we're pretty negative, right? Who knows what the slope is here? Maybe it's like -1 or something. Not quite sure. However, it gets less and less intense over time. Maybe the slope over here is like -0.5. Maybe the slope over here is like -0.2. Here, the slope is 0. We're getting more and more positive throughout our journey right here. So meaning we are concaving up. Our slope is getting faster or more forward in the positive direction. You can think of it that way as well. So from this interval, we are, so it'd be pi to 3 pi over 2. We're negative slope, but we're tending toward the positive direction. So obviously, final window here, when do we have a negative slope and when are we concaving down, or when is our second derivative less than 0? It's this guy right here. And with that interval, we are negative, and we're getting more and more negative. We start off at like negative point, well, 0 really, but negative 0.1, negative 0.2, negative 0.3, okay, negative 1. We get more and more negative in this window, so we're going from pi over 2 to pi. So that's why you see concave up, concave down. Within this window, we're concaving up. Within this window, we're concaving down. Anyway, that was a calculus concept check for you. Math on, I'll do the same. See you in the next video.